Hello, this is Habeebullah and this is my talk about description of the longest valid parenthesis challenge. So this is I'll be completing this challenge in Python 3, and let me go through the explanation of the challenge. I'll explain the constraints, the description, and then I'll go through a quick description of my solution. Then I'll go straight ahead to code my solution, and I've added some extra test cases, and we'll test them out and see if the code works. So basically, the challenge is to count the longest valid parentheses we have in a string. So we'll be given a string that only contains parentheses, that's the open one and the closing parentheses, and we're to return the length of the longest well-formed parentheses. So looking at example one, we can see we have open parentheses, we have a string s that has an open parenthesis, another open and a closed, and the longest valid here is meant to be 2, so which is 1, 2. So that makes sense. So we have an open and closed, that's 2. In example 2, we have a similar situation where it has an open, it starts with a closed bracket, but it has 1, 2, 1, 2. So that's 1, 2, 3, 4. So that's 4 open, close parentheses. And for example 3, you can see where we don't have any parentheses, it should put 0. And for the constraint, it says the length of s can be anywhere between greater than 0, either 0 or greater than 0, and maybe 30,000. So that shouldn't be an issue. And just to reiterate, any character in the S string is either an open parenthesis or closed parenthesis. Okay, so now, I will be using pseudocode just to explain the concept of how I solve this challenge, and then I'll go ahead to code the actual solution, which actually solves the challenge. So, we'll be using example one as a sample. So now, assuming we have a string here, so we have first open bracket, another one, and a closed one here. So we have our string here. So the to solve this, we'll be using maybe a programming concept, which is a stack. So what happens here with a stack is, imagine like you have a big cylindrical, like wide bowl, and which is only open at the top and it doesn't open at the bottom. So if you just put plates, like round plates in it, if you put one, you put two, you put three, if you wanted to get your first plate you put in, you would have to take out the third, the second before you could get to the first. Basically, first in is now last out. So you can't take out that first thing first. You have to take out the third, second, and get the first. So that's basically what we're dealing with. It's called a stack. So in programming, that's what it's called, a stack. So we'll be using a stack in this case. So now we'll be using this stack to keep track of the indexes so that we know when we have an open parenthesis and we know when we have a closed one, and then we can use that to calculate how many of them we have. So we initialize our stack. We have an empty stack here as a list, and then so let's get started with counting. So then the next step, the next component of my solution now includes what we do when we have a open parenthesis and a closed parenthesis. So what happens when we have an open parenthesis is we take the index and we add it to our stack. That's good. Secondly, the most important one is when we have a closed parenthesis. A couple of things happen here. When we have a closed parenthesis, we take out that index, meaning that, okay, we're done. We take out the index that was just put in there. It doesn't matter if it was from a closed or an open one. Whatever index that was just added to the stack will be taken out once we reach a closed parenthesis. That's the first thing that happens. Second thing that happens is we then calculate, because it just makes sense. You have a valid parent to have a valid parenthesis, you have to have an open and a closed, but it always ends with a closed. So anytime we have a close, we just have to calculate and check, do we have any more valid parentheses or was that just a one-off? So we calculate. And thirdly, seeing as every time we have a closed one, we've already said we remove what was inside the stack. In the case where we have an empty stack, then what we do is we return we put in the index of that closed parenthesis so that that is now the starting point where we count from. So I hope that was a bit clear, but we'll go further as I'm sure you'll be able to understand by the time I go through the pseudocode and we go through the code in itself. So now to explain what I just said now, so we go through the first character. The first character is an open bracket and it's at the index 0. So we put a 0 in our stack. Then we have our second character, which is also an open bracket. So we put a 1. Now we move on to the last character, which is now a closed parenthesis. Now, this closed parenthesis, what do we do when we have a closed parenthesis? We pop out. So we take out the last index that was put in, which is 1. So that goes out, and we have a 0 remaining. So now the question is the second thing we do with when we have a closed parenthesis is we calculate how long the longest valid parenthesis is. So our longest parenthesis is, note this is pseudocode, so that's why I'm not using camel case. So longest parenthesis. So how do we calculate this? Now what we use is the index of the close parenthesis, which is this, which is going to be 2 subtracted. We subtract it from the value inside the stack, the last value inside the stack. So the last value inside our stack now is 0. So that gives us 0, and that's equals to 2. So that gives us what we have here. So that's basically how this works. And I could quickly go through the second example that has this, this, and this. So we have our stack initialized empty. Then, so we start from here. So now we have a parenthesis, a close. We start with a closed parenthesis here. So what do we do when we have a closed parenthesis? We remove, we pop out, but there's nothing to pop out here. So what do? We put 1 in, and also we're supposed to calculate the longest parenthesis, but since we're just starting, we know it's definitely 0, so there's no need to do that. So we put it back in, put in a 0. So we start again. We have a open parenthesis, that's a 1, because it's at the index of 1. Then we have a closed parenthesis again. So what do? We take that out. Once we've taken that out, the next thing we do, we calculate our longest parenthesis. So right now we're at our second position also. So that's 2 minus, what's the last thing in the stack? That's a 0. So that's a 0. 2 minus 0 gives us a 2. So for now, we have our longest parenthesis at 2. Now, moving forward, we move to the next one. So this is where we are at. So we move to the next character, which is an open parenthesis, and that's at the third index. That's 0, 1, 2, 3. Third index. We move to the next one, and that's a closed parenthesis. So what do when we have a closed parenthesis? We remove what's in it. So 3 goes out, we only have 0. And what do we do again? We have to count. How long is our longest parenthesis now? So what point is this? This is at which index is this? This is at the fourth index, which is 1, 2, 3, 0, 1, 2, 3, 4. So what do? We do this calculation all over again. So initially we had 2, but now we're going to do the calculation again. So now we're at the fourth index. That's 4 minus, what do we have in our stack? 0. So that's equals to 4. So our longest parenthesis right now is 4, and it's no more 2. 4 is bigger than 4 is more than 2, so therefore our longest parenthesis is 4. So we can clear this off, and now we have 4 as our longest parenthesis. Now we still have one more character, so we move on. So this is now a closed bracket. So What do we do when we have a closed bracket? We delete what we have in our stack. The last item we have in our stack, that gets popped out. And since it's empty, what do? We put in back a 5 because this is at the fifth element index. So that's 0, 1, 2, 3, 4, 5. So we put in a 5. So, and last, what do we now do? We calculate. So, well, how do we do that? We pick the index, which is 5. That's minus what's in the stack, which is also 5. And that gives us a 0. So clearly that is in the longest parenthesis. And since that's the end of the string, then we know clearly our longest parenthesis is 4. So that's what we have here. So we have 4. So I hope that made sense. And now one last case we have to also talk about. It's an edge case where if we have a situation where, for example, our S and we only have 2 brackets. So basically, based on what we understand, this should give us 2. But if we follow our normal method, which I just explained now, we won't get 2. And let me go through this real quick. So we have our first bracket here. We have our stack here, initialize. Okay, you know what? I'm do this on a second place just to make this clear. So that's S. We have just an open and close bracket. Now, so we have a stack. We initialize it. Empty stack. Okay, so we go through the motions. So we have an open bracket at index 0. We put a 0 there. Then we go forward. Then the next character we have is a closed bracket. So what do? We remove our 0. Okay, and since it's now empty, we put it back in. Then what's that at? What's the closed bracket position? That's a 1. So we're putting it back a 1. So, and since we have a closed bracket, we're supposed to calculate the longest parenthesis. So calculating the longest parentheses, what do? We take the index of the closing parenthesis, which is 0, 1, minus what we have in the stack, which is 1. That gives us a 0. So you see, now this is an edge case where we have valid parentheses, but it's still giving us a 0. So to solve this, what we do is we initialize the stack with a -1. So now once it's initialized as a -1, what happens is, in our case, if we redo this again, we have the first one, open bracket, we add it in, is at 0, fine. We have a second one, close bracket, we remove our 0, okay, that's cool. Then we come down to calculate our longest parentheses, and position of a closing bracket is at 1. That's minus what's inside the stack, which is a -1. So we do this, -1, and that gives us 2. So that's basically how this works. So I hope that was clear. Now we go ahead to code our solution. Okay, so we start by initializing our stack. There's a list with a -1. Then we have a variable for our longest parentheses. We'll initialize that at 0, saying as we have nothing for now. So then we start with a for loop to iterate through the string so we can get access to each character. So for I in character enumerates the string. So this will give us both I for the index and char for the character itself. And then we go ahead. So then we do an if to check the character itself. Now if char is equal to open bracket, that will be our first test. The opening bracket Then to the stack, you append the index position of that opening bracket. Else, that means since we've already been assured that S is either an opening or a closing bracket. So if it's not going to be an opening bracket, then it's definitely a closing bracket. What do? We pop it out, meaning we pop out the last thing that was in the stack. That means the last index that got added to the stack will be removed here. Then, but now the second edge case we have, if you remember, was that if you pop out and there's nothing in the stack, we have to put in back the index of that closing bracket. So that's what we're going to do now. So now, if not stack, then we do stack the append the I. But if it's not empty, that's when we can go ahead to do the calculation. Then we calculate what's the longest valid parenthesis. So we have an else here again. And then we calculate the longest parentheses. Now, so the whole code goes on one line. I'll just break that, come back here. So we use a max function because, as we know, we're using a for loop, so we're iterating through the whole character. So we have an updated longest parenthesis. So because you could have just 2 or 4 at the beginning and have another 8 at the end. So we don't want it to make it static. It's not just once. So this max function helps us to calculate if the new one is going to be bigger than the last one, then it chooses the new one. If not, it sticks with the last one. So max longest parentheses in it. And so how do we do our calculation? So we take the index of the closing parenthesis minus stack minus 1. That is the last index that got added into the stack. So that's what we do a subtraction of that. If that's more than the last saved one, then that will be the new longest parenthesis. If that's not more, then then you just continue with the loop until you get to the end of the string. So basically that's it. Then at the end, after going through the whole string, just return longest parentheses. Okay, so that's it. And if we run that, see, it's passed all the test cases. If we go through it, you can see case 1, we have similar to example 1, we have expected, same as expected, now plus 4, expected is 4, that's same as example 2. Case 3 is same as example 3. I added now case 4, which has just 2 for our edge case to show how edge case works. And case 5, we have, yeah, so I created this, and here we have 8 of them. So basically 1, 2, 3, 4, 5, 6, 7, 8. But as you can see, we have another set here, 2. We have a set at the beginning also. So I just added this to make it more complex. But as you can see, our solution covers all and any cases. So yeah, thank you very much for listening. I hope that was clear. Yeah.